Okay, again, recording at lunch, so you're going to hear a series of bells, but that's okay. We'll survive. Today we're going to look at 6-1, law of sines. Okay? So, the law of sines is used to find missing pieces, parts of triangles. Okay? And it's A over sine big A, side B over sine big B, little over sine of angle C. Okay, so A over sine of angle A, B over sine of angle B, C over sine of angle C. Now, there is, you remember from geometry, ways to prove triangles congruent, right? You had side, 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 angle, side, angle, angle, side, angle, side, angle. Okay? These are the ones we're going to be looking at today. So it's going to be looking at where you have two angles. So the law of sines is going to work with these two, and these two are going to be the law of cosines that we'll do tomorrow. Now remember back in geometry how we told you you couldn't do angle side side, right? We said, ooh, that's spelled bad, bad word, can't do it, no way. Okay, and then you guys would be creative and try to do that, and we were still like, nope, 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 bad word backwards, bad, bad, bad. What you're going to learn today is why that didn't work. Okay, it's going to give you, quite potentially, it could give you a triangle, two triangles, or no triangles. All right? So here we go. Example 1. It's going to say, solve the triangle shown. Round side lengths to the nearest tenth. Alright, so let's say that angle A is 50, angle C is 33.5, and side B is 76. Now, this one we don't have to worry about anything because I have two angles and the included side. So this is an angle, side, angle. So I know that only one triangle exists. So when you solve it, remember that first thing you want is you want to know what this angle is. Alright, well how many degrees are in a triangle? So the first thing we're going to do is find angle B. I'm going to do 180 minus 50 and 33.5. So I'm going to do 180 minus 83.5. And that's going to give me 96.5. And again, realize I just sketched the triangle. I don't have to be accurate with my sketches. Now I want to find these missing sides. Do you agree that opposite A is little a, and opposite C is little c, which means the 76 was little b? So now we're going to go ahead and plug into our formula. So little a over sine of 50 equals 76 over the sine of 96.5 and c over the sine of 33.5. Alright, well this is a proportion. What I'm going to do is go ahead and chop it into two pieces. So I have a over the sine of 50 equals 76 over the sine of 96.5. And likewise, I have, let me get a different color out of my pouch here. I have 76 over sine 96.5 equals C over 33.5. So we're going to go ahead and solve this proportion. So I'm going to cross multiply. So I have A times the sine of 96.5 equals 76 times the sine of 50. Now, to get A by itself, what would you do? You'd divide by the sine of 96.5. So I get A is equal to, grab your calculators, again, make sure you are in degrees. So I'm going to type in 76 sine 50, make sure you close that parenthesis, divided by sine 96.5. And I get that little side A is 58.6. Now I'm going to find little c the same way. So I get c times 96 sine 96.5 equals 76 times the sine of 33.5. And I noticed, guys, I forgot to put sine in here, so can you add that back in? To get c by itself, I divide by the sine of 96.5. So I'm going to type into my calculator. 76 times sine 33.5, make sure you close that parenthesis, divided by the sine of 96.5. And I get that little c is 42.2. Okay? Now, we want to talk now about that the ambiguous case, which is when you have side-side angle. What can happen when I give you two sides and an angle? It can set up to where you have one triangle, two triangles, or no triangles. Alright, so let's start off with example 1. Solve each triangle. Round sides to the nearest tenth. And angles to the nearest degree. Sorry, this is example 2. Alright, let's say that A is 43 degrees, little a is 81, little b is 62. So you're going to go ahead and sketch a triangle. It does not matter what it looks like. So don't feel like you have to be perfect in your drawing. Alright, I just sketch an old triangle. I label it A, B, and C. Now I fill in. Angle A is 43. Little a is opposite angle A, 81. And little b is 62. So first let's look at it. Do you see why this is an angle side-side? So this has the potential to be a problem child. So we're going to go ahead and start out and give them the benefit of the doubt and be like, you know what, maybe you're not a problem child. Do you agree that I need, let's see, I need a little c, and then I need these two angles. So let's start with what we know. We know 81 and the sine of 43. Now, do you agree that this isn't going to help you? You don't know angle C and you don't know side C. So even if you tried to write it, you'd end up with that. So you got two variables, which is not working. But here I get little b is 62 over the sine of b. So even though I can't do anything with this right now, I can start here. Alright, so let's go ahead and start there. 81 over the sine of 43 equals 62 sine of b. Alright, so let's cross multiply, and then we're going to solve for b. So I have 62 times the sine of 43 is equal to 81 sine of b. So the first thing I need to do is try to get b by himself. So let's go ahead and divide by 81. Alright, I'm going to go ahead and type this into my calculator so I don't have quite so much to keep in my head. So 72 sine 43 divided by 81. And I get 0.5520 is equal to the sine of b. Now, how do you get b? If you're looking for an angle, do you remember taking the inverse sine of both sides? So I'm going to take the inverse sine of 0.5520. And I find out that angle B could be 33.5 degrees. Okay? So, now what I need to do, because he was an angle side, which is a naughty guy, I got to make sure that that's the only potential angle for B. Okay? So I'm going to go ahead and put the 33 here, and I'm going to say, but wait. What if this was an obtuse angle? Because isn't sine positive in quadrant 2? So isn't it possible that that angle would be in quadrant 2? So my question would be, if I have another triangle where B is obtuse, well, in quadrant 2, think about it, if I have a 33.5 degree angle here, how would I get this angle in quadrant 2? I do 180 minus 33.5. So 180 minus 33.5 gives me an angle of 146.5. Is that possible? So that's your question. Is this possible? Well, what do I know? I know 43 plus 146.5 is equal to 189 degrees. How many degrees can a triangle have? Which is greater than 180, so this is not possible. Which means I truly only have one triangle. So, if you have an angle side, you have to do a quick test to find out how many triangles you actually have. Alright, so let's go back to this guy. So now how does that help me? I now know that angle B is 33.5. Can't I now find angle C? And if I know angle C, can't I come over here? So now I can find that angle C is 180 minus the 43 and the 33.5. So 180 minus 43, 33.5 gives me that angle C is 103.5. It said round that to the nearest degree. I'm going to go ahead and just leave it. 103.5. I'm going to break the rules. What a renegade. Now you know this angle. So now I can come over here and finish this up. So now I know that this is really the sine of 103.5. Now, you have a choice to make. You could choose this, but what happens if you got B wrong? Then you're in a pickle. So I'm going to focus just on these two. Alright, let's use green. So I'm going to do 81 over the sine of 43 is equal to C over the sine of 103.5. Cross multiply. So I get C times the sine of 43 equals 81 times the sine of 103.5. And I apologize, I'm working in this really squished space. So to get c by itself, I divide by the sine of 43. So I get c is equal to, grab your calculator, 81 sine 103.5 divided by sine 43. And I find out that angle, or side C, is 115.5. And you know what, guys? I really should have rounded him to 34, and then we wouldn't have had this extra, and he's not a degree. Alright, so I will obey the rules on the next example. Alright, let's try another side-side angle. So number 2. Let's say that angle A is 75 degrees. Little a is 51, and little b is 71. Okay, again, I like a picture. Your picture does not have to match anything I gave you. I just need a picture. So I put that angle A is 75 degrees. Little a, remember little a is across from big A, it's 51. Little b is across from big B, 71. Alright, so I know that I'm doing A over the sine of A is equal to B over the sine of B is equal to C over the sine of C. Okay, so A I know is 51 over the sine of 75 equals 71 over the sine of an I don't know angle. And here again, I'm stuck. I got nothing. So I'm just going to have to wait on him. So what I want to do is say, well, let's go ahead and solve this and see what I've got. Okay, so we're going to go ahead and cross multiply. So I get 71 times the sine of 75 is equal to 51 times the sine of B. You're solving for B. So let's go ahead and divide by 51. So I grab my calculator. I have 71 sine 75 divided by 51, and I get 1.3447. How do you get B by itself? I'm going to go ahead and take the inverse sine of both sides. So when I hit inverse sine 1.3447, I get an error. The reason you get an error is because what does sine oscillate between? Positive 1 and negative 1. So this is too big. So you have no solution. So this is a triangle that doesn't work. So now I'm done. You're like, man, give me all no solutions, Miss Hoffman. Please, 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 please. Okay? Alright, let's do the last one. We'll at least get it started. We may have to finish it in class tomorrow looking at the timer. Alright, so the last one. Let's say that we know that angle A is 40 degrees, little a is 54, and little b is 62. Alright, so sketch your little triangle, A, B, C. So angle A is 40. Little a, right across from angle A, is 54, and little b is 62. So again, do you see that he's an angle side-side? So I've got to be careful. So let's start off with our formula. I know little a is 2 sine 40, as little b is 2 sine b, as little c is to sine c. So again, I'm stuck here, can't do anything with him, but I can start here. So let's go ahead and try. 54 over the sine of 40 equals 62 over the sine of b. So let's cross multiply. So I have 54 times the sine of b is equal to 62 times the sine of 40. I'm going to divide by 54. So 62 times sine 40, close that parenthesis, divided by 54. Okay, well that's good. At least I'm not going to get an error this time. 0.7380. Alright, how do I undo this? I take the inverse sine of 0.7380, and I'm going to behave myself and round that to 48 degrees. So, B is 48 degrees. Because B is valid, because there was an angle, but wait, I need to test. So come down here and say, what if angle B was in quadrant 2? What would he be? Well, he would be 180 minus 48. So 180 minus 48 is 132. Now do a quick test. If these guys are over 180, this triangle doesn't exist, and I just have to worry about the first one. But what is 132 and 40? That's 172, which means this triangle exists with an 8-degree angle. Alright, we'll pick up there tomorrow. You guys have a great evening, and I'll see you tomorrow.